Okay, let's take a look at the final exam review for Chapter 3, which deals with systems of linear equations. A system of equations is just multiple equations. So a system of linear equations is just more than one line on a graph, and that line can represent many different things. Let's take a look at the first example, a word problem that involves two different models for the price of an amusement park. Both models contain a constant, and both models contain a variable that changes. And that constant is the entrance fee, and the variable that changes is the number of rides, or the number of tickets. So, we have the Crazy Carnival amusement park, which charges 20 bucks for its entrance fee, and 25 cents per ride. That gives us the cost of that amusement park. Then we've got the Happy Fun Time amusement park, which has a very similar model. It has a constant, and that's 15 bucks to get in, and it's 75 cents per ticket. So, both of these models represent the total cost of the amusement park. The question is, for what number of tickets is the total cost of the entrance fee and ride tickets the same for both parks? And that's essentially asking for what value of x makes these equations equal to each other. Well, we can set the equations equal to each other because they are both essentially y equals 20 plus 0.25x and y equals 15 plus 0.75x. So we're basically saying y equals y, or the cost equals the cost. And in this case, we can then solve for the value of x that makes these two models equal to each other. We go through our standard algebraic steps to solve for a variable, combine like terms, add or subtract terms away from the variable, and then multiply or divide to create positive 1 as our coefficient. And we can see here that x equals 10, which means 10 tickets. So if you buy 10 tickets at either of these amusement parks, it will cost the same amount of money. Okay, let's take a look at our next example. This is the substitution method, which should look pretty familiar because we basically just used the substitution method in the previous problem. We substituted one y value for the amusement park into the other. The substitution method tells us that if we can isolate one of the variables in one of the equations, we can then take that value and substitute it into the other equation. For instance, we have two equations here. One of them already has one of the variables isolated, y equals 2x plus 1. That means we can take the value 2x plus 1 and substitute it into the other equation for y, because y and 2x plus 1 represent the same value. And you can see that happen right here. So instead of x plus y equals 10, we have x plus 2x plus 1 equals 10. That allows us to actually get a value for, in this case, x. Again, we combine like terms, solve for the variable, and we see that x equals 3. We are then able to take that value and put it back into the other equation. We can actually take that value and put it back into either of the equations, and we should get the same value for y. We put that back in, substitute 3 in for x, and we can see that y is equal to 7. This creates our solution. Remember, the solution to a system of linear equations is an ordered pair. It is the x-y combo that makes both equations true. If we are using the graph and check method, for example, when we graph two linear functions, we graph two lines, the solution to that system of equations is the point of intersection. It's the x-y combo where the lines intersect. Let's take a look at our Last example, combination. We learned that if we have two equations, we can literally add or subtract full equations from each other. We have to make sure that the like terms are aligned. And in these two examples, they are. The x terms are lined up with the x terms, the y terms are lined up with the y terms, and the constant values are lined up with each other as well. We are looking for coefficients that are either the same or opposite values of each other. That will allow us to either add or subtract to cancel that particular variable. In this case, we have positive 3x and positive 3x. That allows us to subtract one equation from the other. And by doing so, we are creating essentially 0x. We are canceling the x terms. Positive 2 minus negative 6, that's where we get positive 8y from. 4 minus 12, that's where we get negative 8 from. We can then solve for y and actually get a value. And here we see y is equal to negative 1, and now we are at the point similarly to substitution, where we have one value. We have one of the parts of the solution to the system of equations. We have the y value in the ordered pair solution set. We take that y value, negative 1, and now we can substitute it again back into either of the two original equations. We can see here that allows us to then create a value for x. And we see that x is equal to 2 when y is equal to negative 1, and that creates our solution 2, negative 1. If we were to graph these two lines, they would intersect at 2, negative 1. Hope this helps. Thanks, everybody.